Okay, let's see that from level 2 last class, we are few questions are left that we will discuss today. After that, we will discuss level 3. It's very easy only. Okay, let's listen carefully. The correct increasing boiling point orders. So here already this type of question earlier only came. What is that reason? How to solve this question? The boiling points is directly proportional to molecular weight. So which having more molecular weight, it has more boiling points. Let's see that correct one is bromoform. It is a bromomethane, bromoform, chloromethane and dichloromethane. First option. And bromoform, dibromomethane and chloroform and chloromethane. Here it is a bromo, fourth option. Let's see bromoform. What is the bromoform? Bromoform is nothing but CHBr3. Is known as bromoform. Okay. And dibromomethane. Dibromomethane means CH2Br2. Next one is bromomethane. CH3Br. And then chloromethane, CH3Cl. C3 bromine atoms are present means it has more molecular weight. Bromoform, CHBr3, and then CH2Br2, and then CH3Br, and then CH3Cl. So the answer is fourth option. So this is the correct boiling point order. Now let's see that 22nd question. Aryl halides are less reactive towards nucleophilic substitution reactions when compared to alkyl halides. What is the main reason, dear students? For example, SN reactions, nucleophilic substitution reactions, reactivity order, alkyl halides are more reactive when compared to aryl halides. Okay, the first one, let's see that one is here the halogen attached carbon is sp3 carbon has attached to halogen, its bond length is more and bond energy is less. The second thing here it is, if you observe that here in aryl halides, the halogen attached carbon is sp3 carbon, sorry, sp2 carbon. It is attached to halogen means bond length is less and bond energy is more. If bond energy is more means the reactivity is decreasing. So that is one important reason. The second reason is here aryl halides are involving in resonance. Okay, this is resonance stabilized. Aryl halides involving in resonance. The lone pair electrons present on halogens, they are involving in resonance and increases the electron density of the end para position, and the halogen and carbon forms partial double bond character. A double bond X, halogen having positive charge and at ortho position negative charge will forms. So that is called resonance, involving in a resonance. So due to the resonance and carbon and halogen bond length is more in aryl halides, that's why the aryl halides are less reactive in nucleophilic substitution reactions. So that is resonance stabilization. Here only one reason they gave, that is second option is correct. Okay, let's go for next question, 23rd. 23rd question. Let's see. It's very easy only. The replacement of chlorine of chlorobenzene gives phenol under drastic conditions. But in the same way, it's very easy. Chlorobenzene is converted into phenol. Okay, here important thing is drastic condition means sodium hydroxide we are treating with high temperature and high pressure, because The aryl halides are less reactive in nucleophilic substitution reactions. Instead of this, chlorine will be replaced when the presence of NO2 groups. NO2 groups are present, just water is enough. Then is converted into picric acid. 2,4,6 trinitrophenol is known as picric acid. Is very important. So its reactivity, this is one first reaction and second reaction. Second reaction rate is more when compared to first reaction rate. Why? Because the aryl halides are less reactive in nucleophilic substitution reactions. Okay, but aryl halides nucleophilic substitution reactions rate increased in presence of electron withdrawing groups. In presence of electron withdrawing groups, NO2 group. NO2 is electron withdrawing group. Electron withdrawing group, it decreases electron density at ortho and it decreases electron density at ortho and para positions. Ortho and para positions. Hence, its rate in nucleophilic substitution reactions will be increases. So, the answer is NO2 group makes the ring electron density decreases at ortho and para positions. Means NO2 groups withdraws the electron density at ortho and para positions. Hence, their rate of nucleophilic substitution reactions will be increases. Okay, students, that is the fourth option is correct. Let's see the next question. Okay, 24th question. Chloroatom in chlorobenzene is ortho and para directing group. Why? Actually, we know that this chlorobenzene is a minus I group, but minus I group and plus M group. Because of the presence of lone pairs, halogens has how many lone pairs are present? 3 lone pairs are present. It increases the electron density at ortho and para positions. So here resonance, the involving in resonance, the halogens, lone pair electrons on halogen involving in resonance. So involving in resonance means resonance effect predominates over the inductive effect. Resonance effect predominates over the inductive effect. That's why the halogen atoms in on benzene or halogen atoms in aryl halides, they act as ortho and para directing groups. Ortho and para directing groups. Okay, so the answer is first one. Let's see the 25th question. Here, alkyl halides means when alkyl halides reacts with magnesium metal. In the presence of dry ether, forms RMgX is nothing but Grignard reagent. Okay, students, this Grignard reagent acts as a nucleophile as well as base. This R minus, it acts as a nucleophile as well as a base. When that it acts as a nucleophile, when it reacts with carbonyl compounds, means electron deficient species, then it acts as a nucleophile. When it acts as a base, any proton sources means anyone gives proton donors, H plus ions are present, then it acts as a base. So the base removes that proton from proton sources, they converted into RH. The remaining product is MgOHX. It is alkane. Okay. The same way this R plus what is present? Cyclohexane is present. Cyclohexane ring. Then bromine is present and reacts with magnesium metal in presence of dry ether. Then forms cyclohexyl magnesium bromide. This is Grignard reagent. When treated with water, forms cyclohexane. What is the product? Cyclohexane. Okay. 1-bromocyclohexane. 1-bromocyclohexane converted into cyclohexane means bromine. That bromine is replaced by the hydrogen atom. How this conversion is possible? First we are treated with the Grignard reagent followed by hydrolysis. Okay, it's very easy. Okay, let's go for next questions. Okay, level 2 is over. Now we'll discuss about that level 3 questions. Okay, level 3, let's see a mixture of PCl3 and PCl5. Both are present. They are heated with ethyl alcohol. Forms 4 moles of ethyl alcohol, CH3CH2OH. Ethyl alcohol is treated with the mixture of PCl3 and PCl5. Both are present and produce 4 moles of CH3CH2Cl. Ethyl chloride is formed. Then what is the ratio of how they are reacted? Means here it is 4 moles is forming means they react with 4 moles of CH3CH2OH. Then what is the ratio of PCl3 and PCl5? We know that PCl3, first we'll write the reaction with PCl3. Ethyl alcohol reacts with PCl3. It is 1 mole only. Ethyl alcohol reacts with 1 mole of PCl3. 1 mole of PCl3 reacts with 3 moles of alcohol. Produce 3 moles of CH3CH2Cl plus H3PO3. Hypophosphorus acid will form. This is the 3 moles over. Now, another left how many moles of ethyl alcohol is present? 1 mole. Then CH3CH2OH. Ethyl alcohol reacts with PCl5. 1 mole. It is also 1 mole. The products are CH3CH2Cl. 1 mole of ethyl chloride plus POCl3 plus HCl. It is 1 mole. So the total, if you observe that total 4 moles of alcohol, C2H5OH reacts 1:1 ratio of PCl3 and PCl5 forms 4 moles of CH3CH2Cl. Ethyl chloride is formed. So what is the ratio of PCl3 and PCl5 in this reaction, dear students? So that is 1:1 ratio only. Because 1 mole of PCl3 can able to react with 3 moles of alcohols. But PCl5 reacts, 1 mole of PCl5 reacts with 1 mole only. So the total product is 4 moles. That's why for producing of 4 moles of ethyl chloride, how many moles of PCl3 and PCl5 we need to utilize? 1 mole of PCl3 and 1 mole of PCl5 is enough, because 1 mole of PCl3 reacts with 3 moles of alcohol. That's why equal ratios is enough for producing 4 moles of ethyl chloride, 1:1 ratio. Okay, let's see that. Second question. Second question, a compound A reacts with PCl5. Okay, A reacts with PCl5, gives DA. reacts with PCl5 and gives compound B. Okay, compound B is on treated with KCN. Is treated with KCN. Okay, on hydrolysis. After that hydrolysis, the product is actually the compound. Let it be. You have to take. This is A. You have to imagine that alkyl chloride, or maybe alkyl, here chlorides they gave, alkyl chloride you have to take. Then that the product B is sorry, A you have to take alcohol, ROH. That how many carbon atoms we don't know, later we will get idea of. Based on the final product we can count these conversions. And the what is that B? According to this, the B is RCl. This RCl treated with cyanides, the product is RCN. The RCN on hydrolysis in acidic medium, the final product is propanoic acid. Propanoic acid, CH3, CH2. The final product is propanoic acid, CH3, CH2, COOH. See here, this CN group is converted into acid. This is R group. This is R. R is equal to C2H5, ethyl group. Now the R is equals to C2H5CN, ethyl cyanide. Now this R is equal to C2H5Cl, ethyl chloride. Now this R is equal to C2H5OH. So what is A and B? A is ethyl alcohol, C2H5OH, and B is equal to C2H5Cl. Okay, ethyl alcohol treated with PCl5 forms ethyl chloride. That ethyl chloride treated with potassium cyanide forms ethyl cyanide. Ethyl cyanide on hydrolysis, frequently we are getting propanoic acid, because due to the addition of CN, CN means one carbon is present here. This one carbon, here two carbons. Alkyl group is two carbons. Total we are getting three carbons. Cyanides on hydrolysis, and the reactant has how many carbon atoms? Product also having same carbon atoms. Here how many carbon atoms are present on product? Three carbons. So that's why alkyl group is two carbons, C2H5. So C2H5OH, ethyl alcohol is A, and ethyl chloride, C2H5Cl is B. Okay students, understood? Okay, let's go for third question. The third question, let's see the electrolysis of sodium ethanoate, means coal-based electrolysis reaction. Electrolysis reaction. Okay, so now the coal-based electrolysis reaction, the electrolyte is sodium acetate, sodium ethanoate, CH3 COO Na. See here how many moles we have to use? 2 moles we need to use. CH3 COO Na, 2 moles. Okay, is on hydrolysis means 2 water molecules we need to use. This is on electrolysis. In first year only we are studied this coal-based electrolysis reaction. This bond will breaks and here it will breaks. At anode, ethane, CH3 bond CH3 plus 2CO2 will forms at anode. And at cathode, H2 gas, this water molecule will be ionized to give H plus and OH. H2 plus NaOH, 2 moles of NaOH will form. This is at cathode. Now, on what is that alkane is formed. The alkane is electrolysis compound B. This is B. Okay, B is ethane. This is on chlorination. Ethane, CH3 bond, CH3 on chlorination. Reacts with chlorine means free radical substitution reaction at 400 degrees centigrade temperature. Then the product is CH3 bond CH2 bond Cl. Okay, this is C. This C is treated with excess of ammonia. See here, excess of ammonia. If excess of ammonia we are used, it is excess means it is limiting. Just 1 mole is only present, then that all molecules are here it is chlorine negative charge and carbon positive charge undergoes nucleophilic substitution reaction and loss of HCl. Then the product is CH3 CH2 NH2 ethylamine. So the answer is fourth one, excess of ammonia then ethylamine. Dear students, it is very important. If CH3 CH2 Cl ethyl chloride is excess, ethyl chloride is excess, NH3 is lower quantity, it is limiting reagent, then we are getting the mixture of primary, secondary and tertiary. Finally quaternary ammonium salts will form. It is excess. It is excess means it will react with 4 moles. Then the product is C2H5 4 times N plus Cl minus plus loss of 3 HCl. Okay, quaternary ammonium salt will form. Okay, when the quaternary ammonium salt will form, if alkyl halide is excess when react with ammonia. Okay, if ammonia is excess, only primary amines will form. Predominantly primary amines are the major product. Already these reactions we are discussed in amines chapter. It is very important. Don't confuse. The answer is not second one. Okay, here excess of ammonia. Here ammonia is excess. Ammonia is excess. So that's why forms primary amines. Primary amine is predominantly major product. If alkyl chloride is excess, then the predominantly quaternary ammonium salts will form. Okay, students, it's very important. Okay, let's go for next question. It's very easy. Already we did this question in level 2 only. A is reacts with SO2Cl2 converted into B. Okay, that B is treated with sodium metal, forms sodium alkoxides. Okay, and B and C, if B and C forms ethers, then what is A? They are asked. A is alcohol, obviously. Let's see that. The fourth question, if A is equal to ethyl alcohol, okay, A is ethyl alcohol, this is treated with SOCl2, the Argent's reaction forms C2H5Cl, ethyl chloride will form. This is B. The byproducts are SO2 plus HCl. Okay, now the again A means CH3 CH2 OH. Again A reacts with sodium metal, means what it will form? Sodium alkoxides, CH3 CH2 ONA, O minus Na plus half H2 gas. Okay, now it is a C product. Now what they said, B and C they react, means CH3 CH2 Cl plus CH3 CH2 ONA. This is B and C, they react. The final product is diethyl ether. CH3 bond CH2 bond O CH2 CH3. It is diethyl ether. Okay, so this is the final product. So this is nothing but this third step is Williamson ether synthesis. Williamson ether synthesis. Williamson ether synthesis reaction. Okay, so the answer is A is ethyl alcohol. So fourth option is correct. So conversions are very, very important for organic chemistry. Okay, now let's see that fifth one. Among the following, which is more reactive towards SN1 reaction? SN1 reactions reactivity. SN1 reactions reactivity is directly proportional to stability of carbocation. Stability of carbocation, and the second one is carbocation is same, but the different halogens are present. In that case, alkyl iodides are more reactive than alkyl bromides, and then alkyl chlorides. This is the correct reactivity order. Now here this iodine, here chlorine is present, and here bromine is present, here chlorine is present. Among that, alkyl iodides are more reactive. Here oxygen is electron donating group, is a electron donating group. Okay, see the stability of carbocation is directly proportional to plus I groups, donating groups, electron donating groups. Here oxygen is nearer to this, then if it is lost, this carbocation is stabilized, it donates that pair of electrons, then it is more stable. That's why the first one is more reactive when compared to second, third and fourth. After that, first, so the reactivity order highest is first one. Next, bromine can leave very easily when compared to alkyl bromides are more. Then third one is more reactive. Now this both are chlorides. Here this is very nearer and it is far. That's why this second is more reactive. And then fourth one. This is the SN1 reactivity order. So the more reactive towards SN1 is first compound. Okay, students. So whenever they are asked SN1 reactivity order means first we have to think about that which reactant can able to form more stable carbocation. That is more reactive in SN1. SN2 reactivity order do you want means which reacts less stable carbocation. Less stable carbocation means because SN2 reactions are single step reactions, transition state intermediate will forms. But SN1 reactions carbocation intermediate will forms. That's why reverse both. SN1 reactivity order is reversed to the SN2 reactivity order. Okay. Now let's go for next question. Sixth one, it's very easy. Silver salts of carboxylic acid means Hunsaker reaction, my dear students. The sixth one is nothing but Hunsaker reaction, first one. So that's why named reactions we have to remember. Immediately we have to identify this reaction, this conversion is belongs to what type of named reaction. CH3, CH2, COOAZ is treated with bromine in the presence of carbon tetrachloride. Carbon tetrachloride is non-polar solvent. Okay, now this product is, it is nothing but Hunsaker reaction. Hunsaker reaction. Okay, now the product is CH3CH2Br. The remaining byproduct CO2, HBr, AgBr will forms. This is the major product. It is X. Okay. Now this reacts with aqueous KOH. Aqueous KOH means it is nucleophilic substitution reaction. Nucleophilic substitution reaction. What type of nucleophilic substitution reaction it is? Primary alkyl halide. Then the nucleophile is equal to OH minus group. So it is SN2 reaction. The second step is SN2 reaction, okay? Because the primary alkyl halides are more reactive towards SN2 reaction. Now the OH minus ion is nucleophile. Then that product is CH3, CH2OH, alcohol. Alkyl halides convert into alcohol. These alcohols again treated with red phosphorus and bromine. This red phosphorus and bromine is nothing but react with PBr3 only, because phosphorus and bromine, they forms PBr3. Okay, here 4 phosphorus, then 4 moles, then 4 3 is 12 bromine atoms, means 6 moles. Phosphorus tribromide will forms. Then alcohols reacts with phosphorus trihalides, forms corresponding alkyl halides. So now the reaction is CH3, CH2Br, the final product. Now this is Z. What is Z? They are asked. Z is ethyl bromide. Z is a ethyl bromide. Okay, clear? Now let's see the 7th question. 7th question is nothing but an alkyl halide is Wurth reaction. It is the application of Wurth reaction. Okay, what is Wurth reaction, dear students? Symmetrical alkanes will form. Alkyl halides, 2 moles of alkyl halides reacts with 2 moles of sodium metal. Then loss of NaX in presence of dry ether. The product is R and R. This is symmetrical alkane. So according to this here, based on that application is product they gave. First we have to identify what is the alkyl halide we need to identify. What is the product? 2, 2, 5, 5 tetramethyl hexane. Tetramethyl hexane means 6 carbon atoms are present. 1, 2, 3, 4, 5 and 6. Okay. Now second portion, 2 methyls are present. 1, 2, 3, 4 and 5th carbon also 2 methyls are present. Now remaining is hydrogen atoms. CH3, CH2, CH2, CH3. Okay, this is 2, 2, 5, 5 tetramethyl hexane. Okay, this is the product. This product, how it is forms in dry ether, in the presence of dry ether. So you have to break symmetrically. 3 carbons means like 3 carbons are in a straight chain, then we can break middle, means the breaking is taking place at 3 and 4th. Here it will breaking will takes place. Here. Now this is one alkyl group. Here halogen you have to add. And here halogens will add. Then we'll get symmetrical alkane. That is 2 moles of CH3 bond C bond CH3